Earth appears white. From space, the planet looks almost unrecognizable. Vast ice sheets stretch across continents and oceans alike. Only dark fractures interrupt the frozen surface, where volcanic rifts continue to cut through the ancient crust. This is not a photograph. It is a scientific reconstruction, built from geological evidence preserved in rocks that still exist today. The contradiction begins far from space. In the dry Flinders Ranges of South Australia, scattered across a landscape that now bakes beneath a hot sun, lie boulders scarred by deep, parallel scratches. The marks are unmistakable. They were carved by moving glaciers. The rocks sit inside chaotic layers of ancient glacial debris. Above them, without any gradual transition, smooth marine limestone records the return of warm tropical seas. Nothing about this landscape suggests that glaciers should ever have existed here. The simplest explanation seems obvious. Perhaps these rocks formed in a cold region long ago, and only later drifted into the tropics as continents slowly wandered across Earth's surface. The investigation begins there. Hidden inside these rocks is another record of their past. Tiny magnetic minerals preserved the latitude where the sediments first formed. When geologists measured that ancient signature, the expected answer never appeared. The rocks had not formed near the poles. They formed within roughly 10 degrees of the ancient equator. The scratches belonged to glaciers. The glaciers belonged to the tropics. One impossible outcrop might still be dismissed as an exception. But similar cryogenian glacial deposits appear on multiple continents. Different rock sequences, different field sites, the same story. Glacial debris preserved where warm, shallow seas should have existed. The investigation changes. This is no longer a question about one unusual cliff in Australia. It becomes evidence that Earth's climate once behaved on a planetary scale. The scratched stone remains exactly where it has rested for hundreds of millions of years. Only its meaning has changed. If glaciers truly reached the equator, then one assumption has already failed. Earth has not always remained as climatically stable as it appears today. One question now refuses to disappear. If even the tropics could freeze, what stopped the rest of the planet from following? The first maps seem reassuring. Even after confirming that glaciers once reached the ancient tropics, it is tempting to believe the freeze stopped there. The equator receives more sunlight than any other part of Earth. Logic suggests that increasing warmth would eventually halt the advance. The geological record tells a different story. When cryogenian glacial deposits from multiple continents are placed back into their ancient positions, they do not form isolated pockets of ice. They outline a pattern spreading across the planet. Rocks carrying the unmistakable signature of glaciers appear again and again, separated today by oceans, but linked by the same interval of Earth's history. The expected climatic barrier never appears. The investigation changes once more. What began as evidence of tropical glaciers is becoming evidence of a climate system that refused to stop cooling. Only after that contradiction becomes impossible to ignore does the mechanism begin to emerge. Climate reconstructions using ancient continental positions show that ice can reach a critical threshold. As frozen surfaces expand, they reflect more sunlight back into space than darker oceans or land. More reflection means less absorbed heat. Less absorbed heat allows even more ice to form. The process begins feeding itself. Each advance of the ice prepares the conditions for the next. The climate is no longer resisting the freeze. It is amplifying it. This is known as the ice-albedo feedback. The principle is simple. Once enough of the planet becomes white, the sunlight that should slow the advance instead escapes back into space. The remaining warmth struggles to overcome the growing reflective shield. The consequence reaches far beyond any single glacier. A regional ice age becomes a planetary process. Field evidence supports the same picture. Across widely separated continents, thick glacial sediments known as diamictites appear within equivalent cryogenian rock sequences. Above and below them lie warm water carbonate rocks, recording climates that were dramatically different before and after the freeze. Between those warmer worlds sits the same unmistakable interval of widespread glaciation. Independent outcrops begin telling the same story. The reconstruction is no longer resting on computer models alone. The rocks agree. The frozen Earth returns. Seen from space, it no longer appears as an unusual world wrapped in ice. It has become something more unsettling. A climate system enclosed within its own success. Every new sheet of ice strengthens the conditions that create the next. The white surface is no longer simply covering the planet. It is trapping it. The expectation that tropical sunlight would naturally rescue the climate has quietly disappeared. A more difficult question now takes its place. If the planet approached this frozen state, where could anything still be alive? The frozen world appears silent. From orbit, the oceans seem locked beneath an immense white shell. Ice stretches across horizons that once reflected open water. If this image represented the whole story, the investigation would already be over. A planet this frozen should have erased nearly everything living on its surface. The rocks refuse to support that conclusion. Deep inside cryogenian sediments, preserved beyond the reach of weather and time, scientists found microscopic fossils, tiny spherical cells, delicate organic walls, the remains of ancient plankton-like organisms known as acritarchs. They do not appear after the glaciations, as though life had begun again. They continue through them. The investigation changes. The expected biological break never arrives. Life did not simply vanish from the geological record. It endured. That discovery creates a larger problem. Where could these organisms have survived if nearly the entire planet was trapped in ice? The answer does not begin with fossils. It begins with a single boulder. Inside the Kingston Peak Formation of what is now Death Valley, enormous stones interrupt perfectly thin layers of ancient marine mud. The surrounding sediment bends downward beneath each rock, while younger layers settle calmly across the top. The sequence records a simple physical event. A large stone fell into soft seafloor mud. But the stone could not have reached that location by rolling across the ocean floor. It had been carried by floating ice. Only after the ice drifted over open water did the iceberg melt enough to release its load. The boulder plunged downward. The mud absorbed the impact. Later sediments quietly buried the scar. The investigation shifts again. If floating icebergs existed, then at least some bodies of water remained exposed, or sea ice remained dynamic enough to calve and drift. The frozen planet was not necessarily a perfectly sealed sphere of motionless ice. The geological evidence allows something more complex. Localized corridors of open water, thin ice near the equator, geothermal environments where heat continued rising from Earth's interior. Exactly where these refuges existed remains uncertain. The rocks do not preserve a map. They preserve possibility. Independent evidence arrives from another direction. Chemical biomarkers and isotope records continue across the cryogenian interval without showing the complete biological reset expected after total extinction. Separate lines of evidence, recovered through different methods, point toward the same conclusion. Microscopic life persisted throughout the glaciations. Not everywhere, not abundantly, but continuously. The frozen Earth looks unchanged from space. Its white surface still dominates the planet. Yet beneath that frozen exterior, the investigation now reveals something that was invisible before. The biosphere never completely disappeared. The world remained trapped. Life did not. Only one question now remains unanswered. If the frozen planet could preserve life for millions of years, what finally broke the ice itself? The frozen surface gives no sign of change. From above, the planet still appears locked inside the same white prison. Continents remain buried beneath ice. Vast frozen oceans reflect sunlight back into space. If the story ended here, the climate would have no obvious path toward recovery. That expectation feels unavoidable. A world trapped by runaway ice should remain trapped. The investigation turns away from the surface. It looks beneath it. Deep below the ice, Earth's interior never stopped moving. Volcanic rifts continued opening through the crust. Magma continued rising. Volcanoes continued releasing carbon dioxide into the atmosphere. Their heat did not melt the ice directly. The amount of heat escaping from volcanoes was insignificant beside the scale of the frozen planet. The recovery began somewhere far less visible. It began in the sky. Under ordinary conditions, volcanic carbon dioxide does not accumulate forever. Rainfall combines with the gas, forming weak acids that weather exposed rocks. Rivers carry the dissolved minerals into the oceans, where carbon becomes locked away inside carbonate sediments. That planetary recycling system had nearly stopped. With much of the planet frozen, rainfall diminished dramatically. Vast regions of exposed rock disappeared beneath ice. Weathering slowed to a fraction of its former pace. The atmosphere continued receiving volcanic gases, but it could no longer remove them efficiently. The investigation changes. The frozen Earth was not becoming warmer because volcanoes were melting the ice. It was becoming warmer because the atmosphere was slowly changing. For millions of years, carbon dioxide accumulated without interruption. The process was almost invisible on any human timescale. Century after century, millennium after millennium, the frozen surface appeared almost unchanged, while the atmosphere quietly became thicker and more effective at trapping heat. The prison had begun weakening long before anyone standing on its surface could have noticed. Only after this hidden transformation does the geological record reveal its consequence. Across Namibia, Svalbard, Arctic Canada, and many other ancient coastlines, dark glacial deposits end with astonishing abruptness. Above them lies a completely different rock. Bright carbonate layers, smooth, continuous, often displaying delicate sedimentary structures that could only have formed after liquid oceans returned. There is no long, gradual transition. The boundary is sharp. The investigation reaches another irreversible turning point. The rocks preserve the escape itself. These formations are known as cap carbonates. They appear directly above glacial deposits across the world, recording an extraordinary chemical shift as oceans and atmosphere rapidly adjusted after the frozen interval ended. Carbon isotope measurements preserved inside these rocks independently support the same sequence of events. A long period of extreme glaciation. Then an abrupt transition into an intensely warm greenhouse world. The evidence converges from multiple directions. Field geology, geochemistry, global stratigraphy. Together they point toward the same reconstruction. The frozen Earth returns once more. From space, the surface still appears almost entirely white. But that image has become deceptive. The decisive change is no longer visible on the ice. It is unfolding beneath the clouds and inside the atmosphere. The planet's interior has continued working through every frozen million years, preparing a recovery long before the surface revealed it. The old expectation quietly disappears. A frozen planet is not necessarily a permanent one. One final question remains. How can a vanished world still be recognized in the rocks beneath our feet today? The ice is gone. No satellite can photograph the frozen Earth that once approached a planetary icehouse. No expedition can stand upon its vanished glaciers. The world that existed during the Cryogenian has disappeared beneath hundreds of millions of years of geological change. Yet its record has not. The investigation returns to the rocks. On modern cliff faces, separated by entire oceans, the same sequence appears again and again. At the base lies chaotic glacial debris. Scratched boulders are locked inside a matrix of crushed sediment, preserving the unmistakable signature of moving ice. In some locations, isolated drop stones still deform the fine marine layers beneath them, recording the moment they fell from floating ice into ancient water. Then the pattern changes. Without a long transition, the disorder ends. Directly above it rests a thick layer of pale carbonate rock. The boundary is so abrupt that a hand can trace it across an exposed outcrop. One side records a world dominated by ice. The other records warm seas returning. The investigation has reached its final test. If this reconstruction is correct, independent evidence should converge on the same story rather than repeating the same measurement. It does. The magnetic minerals preserved within the rocks still point back toward tropical latitudes during the glaciations. Carbon isotope measurements preserve the extraordinary chemical transition that followed the melt. Stratigraphic correlations connect equivalent rock layers across continents that were once joined in a very different arrangement of Earth's surface. Each line of evidence was gathered for its own purpose. Each arrives at the same sequence. Glacial deposits. Floating ice recorded by dropstones. A rapid shift into widespread carbonate deposition. The reconstruction no longer depends on any single outcrop, any single laboratory, or any single hypothesis. The rocks reinforce one another. The case closes through accumulation, not repetition. The frozen Earth returns for the last time. It is no longer seen from space. It no longer appears as a reconstructed white planet enclosed by ice. It exists instead within a narrow band of stone running through a cliff face. The object has not changed into something else. Only its form has. What once surrounded the planet now survives as a thin geological boundary that can be touched with a hand. The world itself vanished. Its evidence remained. Standing before that contact, the contrast is impossible to miss. Dark glacial deposits end almost instantly beneath bright carbonate rock. The transition records one of the most extreme climate reversals preserved anywhere on Earth. The ice disappeared hundreds of millions of years ago. The record of its arrival, the record of its escape, still remains inside the planet that survived it.